Hello, hi everyone, welcome back to my channel. So this is Ramandeep Singh, and today in this session we will be solving a lead code problem. This is going to be a lead code session. So the problem that we will be solving would be this minimum threshold path with limited heavy edges. So this problem we will be solving today, and the problem is from maybe recent contests from LeetCode. So there are weekly contests on LeetCode, and I think the problem has been taken from that particular contest. ठीक है, तो चलो सॉल्व करते हैं इसको. Let's jump to the problem solving part. Hey there, welcome back. So let's start with the problem solving thing. So we have this problem which is minimum threshold path with the limited edges, with the limited heavy edges. Okay. So let's read the problem statement. So what we have been given here is like there is an undirected weighted graph with the n nodes labeled from 0 to n minus 1. ठीक है, तो हमारे पास एक वेटेड ग्राफ है. द वेटेड ग्राफ हैज़ n नोड्स. ठीक है, and the nodes are labeled from 0 to n. The graph is represented by a 2D integer array edges. So we have an array 2D array called edges, and the graph is represented by these edges. ठीक है, so all we have to do with each edge, so a particular element in that edges array is a tuple containing 3 integers u, v, w, where there is an edge between u and v with the weight of w. Kind cool है. And the edge is undirected, so there is an edge from u to v and v to u. You are also given integers source, target, and k. So 3 integers has been given apart from the information which we had earlier. That is source node, target node, and k. A threshold value, so now it defines a term called threshold. A threshold value determines whether an edge is considered light or heavy. So an edge is light if its weight is less than or equal to threshold. So there is a particular value called threshold. If the edge, the weight of the edge is less than or equal to the threshold, that particular edge is light edge. If the weight of the edge is greater than that threshold, then that edge is heavy edge. So we have two types of edges in the graph. Cool. Now, a path from source to target is valid if it contains at most k heavy edges. तो सोर्स से शुरू करके टारगेट तक कोई पाथ लेते हैं. देयर कैन बी मल्टीपल पाथ्स क्योंकि इट्स अ ग्राफ है ना. सो एनी पाथ इज़ वैलिड इफ़ इट कंटेन्स एट मोस्ट के हैवी एजेस. ज़्यादा से ज़्यादा के हैवी एजेस उसमें हो, देन दिस पाथ इज़ अ वैलिड पाथ. सो वी हैव टू रिटर्न द मिनिमम इंटीजर थ्रेशोल्ड सच दैट एटलीस्ट वन a valid path exists from source to target. If no such path exists, then return -1. So just find the first true value or the first threshold value where there is a valid path from the source to the target. So it's more of like, so there is a monotonicity for this threshold value, like why. So let's see. So let's say we have values like 1 2 3 4 5 6 7 8. कैपिटल करते हैं इसको. तो इस तरह से कुछ वैल्यूज़ है. ठीक है, एंड लेट्स से 4 इज़ माय थ्रेशोल्ड वैल्यू. सो 4 इज़ अ नंबर वेयर फॉर एनी ग्राफ, लेट्स टेक यही ग्राफ ले लेते हैं. So let's say this is the graph. इसी ग्राफ को लेते हैं. So let's take this graph, and the source that we have been given is 0 and the target is 3. So source, target, and k has been given as follows. ठीक है, now source is 0, target is 3, and k is 1. That means we want to start from 0 and we want to end at 3 and find if there is a valid path for the minimum threshold value. So what is that minimum threshold value? So let's say the minimum threshold value we find here is 4. So 4, let's mark it green. तो ये मेरी minimum threshold value है. So when like what does that mean? Means we need at least four heavy edges, है ना? We need at least four heavy edges, है ना? Four heavy edges, right? 0 से 3 जाना, four heavy edges maximum, at most k heavy edges. ठीक है, yeah. Sorry, so we can have at most k heavy edges, not four heavy edges. We can have at most k heavy edges. So k is 1. So whatever path we are taking from the source to the target, the source is 0, the target is 3. So there can be, like here in this case we can see there is only one path, 0 1 4 3. So we move from 0 to 1, then from 1 to 4, then from 4 to 3. Okay, so this is the only path that we have, like 0 0 to 1, 1 to 2, no, not 2, 4, 4 to 4 to 3, right? And so the condition is in the path that we have taken, we should have maximum k heavy edges. So how to decide that the heavy edges, how many heavy edges are? So in this path from 0 to 3, how many edges we have? We have one edge. This is 0 to 1 5, then from 1 to 4 2, then from 4 to 3 4. So what minimum threshold value we should decide such that in this path we have at most one heavy edge. So what is the heaviest edge here? 5. So we can think of it like, if we take the threshold to be 4, then we will have, like, let's take the threshold to be 4. So if any edge has a weight greater than 4, that edge is considered as heavy, otherwise it is a light edge. So from 0 to 1 we have 5, so this is a heavy edge. So from 0 to 1 this is a heavy edge, so let's mark it red, heavy edge. Now from 1 to 4, 1 to 4 2, 2 is less than 4 because threshold we have chosen as 4. So this is a light edge, this is a light edge. Now let's from 4 to 3, the edge weight is 4. This is also a light edge, this is also a light edge. So in this path we can see that we have at most one edge as the heavy edge. So this is a valid path. So if we take threshold as 4, then yes, the answer is yes, we can have a valid path from this source to the target. Less than this threshold 4, can we have? No, we can't, because let's say if we take threshold to be 3, then 0 1 is a heavy edge, okay, 1 2 is a light edge, and 4 3 is a heavy edge. So we have two heavy edges. So threshold 3 means two heavy edges. Threshold 2, if the threshold is 2, in that case also we have two heavy edges. If the threshold is 1, in that case we have 3 heavy edges. But we can see that we can have at most one heavy edge. So the minimum value where this condition is satisfied is 4. Now if the threshold is 4, the value is satisfied, we have a valid path. If the threshold is 5, even in that case the condition is satisfied. So let's say if the threshold we take as 5, then how many heavy edges we will have? 0 to 1, it's 5, so that is a light edge. 0 to 1 5, threshold is 5, light. 1 to 2, 1 to 4, value 2, threshold is 5, light edge. 2 to 3, 4, weight, and threshold is 5, light edge. So 3 light edges. We do not have a single heavy edge here, okay? So that means this is a valid path. So 5 is also valid, 6 will also be valid, 7 8, all the numbers will be valid. But we want this 4. This is my answer. Now we can see the monotonicity here. Once the value turns to true, it stays true, it will not turn back to false. So how will we solve this problem? It's obvious. So we will use binary search to solve this problem, and so we will use binary search here. So what will be left? Left is 0. What will be right? What right will be 1e 9 plus 7. Why left we have taken? Why the range is from 0 to 10 to the power 9? So threshold can be 0 as well. Threshold can be 0 as well. So that's why left is 0. Okay. Let's create answer variable. Let's initialize it with -1. Then while left less than equal to right, and mid left plus right minus left by 2 if is valid, mid. Yeah. So we have been given edges, so we have to create the graph. So let's create the graph. Vector of pair, adjacency matrix n plus 5 for r2 it edges atj it 0 dot push back it1 comma it2 atj it1 dot push back it0 comma it2. ठीक है, लाइक दिस. ठीक है, हो गया. Graph बन गया. And once we have the graph in place, so we will have this n mid, फिर adjacency matrix, फिर और क्या होगा इसमें? मिड हो गया, एन हो गया, एडजस्टमेंट के हो गया. एनीथिंग एल्स? ठीक है. आंसर फर्स्ट लेफ्ट would go out of hand. ठीक है, कूल है. So now this is the boolean function valid. So this says, okay, if this particular mid is valid, then look for a better one towards the left. ठीक है. So how do we check if this mid is valid? If this threshold is valid. In order to check that if a particular chosen threshold is valid or not, we will have to move from the source to the destination. We have to find the path. So which path? Not all the paths. There can be multiple paths in the graph, but we will have to find the shortest path. Shortest in terms of what? Shortest in terms of weights. Shortest in terms of uh, heavy edges, like which the path which contains minimum heavy edges, the path which contains minimum heavy edges. So the same graph, so how do we find that? So we have two types of edges, either a light edge or a heavy edge. So light edge means, let's mark it, label it as 0. Heavy edge, label it as 1. So from 0 we have a edge which from 0 to 1, and this has a weight of 0. Then from 1 to we have an edge to 4 which has a weight of if the threshold chosen, so the threshold chosen is let's say the threshold chosen is 4. So if I choose threshold to be 4, then this would be 1. Why? Because 5 is greater than 4, so this is a heavy edge. 1 to 4 is 0. Why? Because 2 is less than 4, so it's a light edge. Then we have this 3 to 4, and from 3 to 4 we have edge, like we have an edge, the weight is 4, so 4 is same as that threshold, so this is a light edge. So this is the path which we get. Now let's change this thing as well. 2. So which type of weight is this? Which type of edge is this? 3 is less than 4, so 0. Then we have this 2, and यहाँ तो क्या जाए नहीं, we have an edge here 5, and here we have 0 again. ठीक है, cool. So now from 0, this is the source, this is your source, this is your destination. So from source to destination we'll have to move. How we want to find the shortest path. So in this particular modified graph we want the shortest path. Okay, now कैसे निकालेंगे? BFS या डायस्टर लगा दो. डायस्टर लगाने की ज़रूरत नहीं है. 0 1 BFS will work. So push this into the queue, push this 0 into the queue, and mark its distance to be 0. Then iterate the adjacent nodes which is 1. Mark its distance to be 1, क्योंकि यहाँ पे हम देख सकते हैं we have this 1. ठीक है, then traverse its neighboring edges, 2 neighboring nodes, एक के neighboring nodes 2 और 4, update their distances. So for 4 and 2 we will update as 1. So it takes only 1 unit of distance to move from 0 to 2 and to move from 0 to 4. Then mark the neighboring of 2, which we do not have. Then mark the neighboring of 4, which is neighboring of 4 would be 3 and 5. So to move from 4 to 5 we take 1 unit of distance. Why? Because 0 1 4 5 contains only one heavy edge, and 0 1 4 3 this also contains only one heavy edge. So at 3 we will have 1, at 4 we will have 1, at 1 we will have 1, at 2 we will have 1, at 5 we will have 1. ठीक है, so that means you see, if you want to reach any node in this particular configuration, then it will require at least one heavy edge. Why? Because the only edge which is emanating from the source 0 is the heavy edge. So if you want to reach any other node, then it has to pass through that edge, and hence it has to be counted, and hence 1 is the minimum answer we will have for any node in the graph. Cool. That means this is how. So just perform the BFS and create a distance array. We all know how to do that. Let's do it. Int BFS, not BFS, is valid, is valid, n mid adjacency list, and फिर क्या है, k. So let's create a queue of जरूरत नहीं पेयर, queue of int distance बना लेते हैं, distance of sizes n plus 5, 29. So we have source and target तो रह ही गया, source target. So we have to pass these two values as well. Source target. Cool. So distance source would be 0. Q dot push source while Q is not empty. Node which is Q dot front, Q dot pop. Now what? अब इसके नेबर पे चलते फॉर so here I will have like two things. You can have it like weight would be distance of the node that we have, so this is the weight. Now here we will have two things, the weight of the edge from the current node to the neighbor node. Current node is this node, so cost. So how would it of 1, if this is greater than the mid, that means 1, otherwise सही है या. तो अब यहाँ पे we will update if distance for the IT0 is greater than distance for what IT1. Did distance IT0 greater than distance IT1 plus what? IT0 तो हो गया वो, एंड नहीं नॉट IT, सॉरी, हाँ नोड से नोड प्लस दिस कॉस्ट. सो दिस इज द नेबरिंग नोड है ना, and this is the node from where I'm coming, and this is the cost from this node to the neighbor one. So if this is greater, then I'll update it. Distance IT0 would be distance node plus cost, and Q dot push this and at the end I will check if distance to the target is less than equal to k, then it's valid, otherwise it's not. So I hope this is fine, this looks good, there is no problem in it. Hope so. Okay. It's not. Okay. Got accepted. Submit करते हैं. ठीक है, सबमिट हो गया and got it accepted and that's good. So what's the time complexity for this? It would be like you can see the time complexity for binary search, which is big of log of this length of this range, which is 1e9, multiplied by the complexity for this BFS, big of, what's the complexity? So how many elements you can have in the queue? We are pushing, what we are pushing in the queue, we are pushing, so the number of nodes we can have n nodes, so basically n in n plus m. So it's like big of log 1e9 मल्टीप्लाइड बाई शॉर्टेस्ट पास को 01 BFS की क्या रहती है n प्लस m. फाइन. Okay, so I hope this thing is clear to all of you people, and we'll see you in the next session. And I hope you enjoyed it, the problem solving thing. I also enjoyed solving this problem, and I will see you in the next one. Till then, bye bye. Take care, ladies and gentlemen.